Hi, hello. This is A.THASNI from Department of Computer Science and Designing from SNS College of Technology. So today we are going to see a topic about computer networks for transport layer. In the transport layer, we are going to see about the SCTP. So SCTP is nothing but standard transport protocol. We have a scenario here. Like imagine you are on an urgent internet or telephony like VoIP call or while streaming a high definition video. Actually, some glitch is happening, like a single packet of background text data is getting lost. So you are getting the frustration, like even though your audio and video packets arrived safely, your computer refuses to play them because it's waiting for that one unrelated text packet to be transmitted. So here the question is, why does one missing piece of mail stop the delivery of all other unrelated packets? So here come the transport layer dilemma, like from the transmission control protocol, your data will be sent as part of reliable and byte-oriented strict ordering and head-of-line blocking. Like one packet delays everything, it's vulnerable to sync flooding. And UDP is user datagram protocol, like unreliable datagrams and no flow control and no reordering and packet loss, which is a targeted one. Like unreliable message oriented is nothing but no ordering or congestion control. Like what it is fast, but that's no guarantee. It provides preserve message boundaries. And SCTP is a solution we found. Like it is reliable and message oriented, and it is configurable ordering, and multi-streaming is possible, and multi-homing also, and it has some independent flows, and it also falls under fault tolerance and resilient to flooding. So the next generation architecture, if you see the association concept, the association is nothing but border relationship in a TCP connection. It encompasses multiple IP addresses and multiple streams. And the multi-streaming is nothing but data is partitioned into independent streams, which is lost in stream 1, which does not block in the stream 2. And multi-homing is nothing but network level fault tolerance and autonomous alternate IPs if the primary path is cut. So next one is the packet anatomy. Packet anatomy, we have something called as common header and variable length chunk. So common header consists of 12 bytes, and this 12 bytes is segregated into source port and destination port, which consists of 16 bits. And its verification tag is 32 bits, which is anti-masquerade, and its checksum is 32 bits, which is a CRC 32C casted mode. And the variable length chunks is nothing but a control chunk, data chunk, and data chunk in stream. First will be the control chunk, which is part of SAC. Next, the verification tag, which is nothing but a 32-bit random valued exchange at the startup. It validates the sender and protects against the blind packet definition. Next one, what is inside the data chunk? Data chunk is nothing normally like a U-bit, like it is unordered delivery. If set, it bypasses sequencing. If it is not set, it will not bypass. So next one is fragmentation flags, which is the beginning and end of the flag. So here type 0 is the data, and the rest of the things are IUBE. So IE is nothing but the initial state, and U is another unordered delivery, and B is the beginning, and E is the end, and the next rest is the length. Next layer is at a TSN, which is a transmission sequence number, which is a global sequencing for reliability. Then stream identifier, which is SI, which is a routing to specific stream and local ordering, and stream sequence number is SSN. Next one is payload protocol identifier, which helps to identify the payload type like SS7 or WebS, RTC, etc. transparently. Next one, user data payload. So how it is associated with the SCTP, which is from one is from the client side, it is called as endpoint A, and another one is from the server, which is called as endpoint Z. So in the initial stage, we initialize the tag A, and we are getting the acknowledgement from tag Z, which is from the server, and it serves the cookie, which the server generates a cryptographic cookie containing state, then discard the state. No memory was allocated on this. Next, it will, once the acknowledgement is done, like client echoes the cookie bar, which server verifies the signature. Once it is verified, next it will be association will be established and resource will be allocated from the cookies acknowledgement. This is how the SCTP is associated. Next one, defending is sync flooding. Like the state of cookie mechanism here we are using like stateless handshake, where the server allocates zero memory until the client returns the valid cookie. This prevents DOS attacks and by offloading state storage to the client. Next one, dual layer sequencing, which is a transmission sequence number, which is a global identification number, we can say, and SA is stream identifier plus SSN is stream sequence number, which ensures order within a specific context. Next one, which comes under the association, which tracks the arrival and gaps used for SAC and reliability. And another one is a stream, which is a separation of concern, which where TSN handles did it arrive safely or not. Also, SSN handles what order do I issue the user. Next one is SAC. SAC is nothing but the selective acknowledgement. How the report structures will be cumulative TSN acknowledgement, which is consists of 12 number. Like I have everything up to here, and gap acknowledgement block 1 with start plus 3 and end plus 5. I received 15 through 17. So the final result will be sender knows the exactly that 13 and 14 are missing. Next one, network fault tolerance, which is comes under the path monitoring, failover, and retransmission. Path monitoring, which idles path are propped with hardware chunks. Failover is if the path exits. Path.max some retrans traffic switches to the alert alternate. And retransmission is nothing but lost packets on the primary or retransmitted via the alternate path to ensure the delivery. Thank you.